Hello, in this video we solved question 2 of K Pure Maths 2025 Unit 1. So part A reads, let B, M, and N be positive real numbers given that log base B of 3 equals M and log base B of 4 equals N. The first part is we're asked to show that log base B of the square root of 27 over 16 equals 3M over 2 minus N. So this is just an application of the log laws, and you have to just be able to do the log laws. So let me just show you how you do it. Log base b square root 27 over 16. The first thing is you can think of it like this. Log base b square root 27 over square root 16. And then the log law tells you can split up the division as log base b square root 27 minus log base b square root 16. Okay, now what can we do again? Well, we know that 27 is 3 to the 3. So then, and the reason I want to use 3 is because I know log base b of 3. That's m. So square root 3 to the 3. And then similarly here, 4, right? But 16 is 4 to the 2. So like that. Now, the square root of 4 squared is just 4. So I could simplify that. But for this one, sorry, I forgot my b. For this one, I have to use the index laws again. The square root is the same thing as to the power of a half. And then I could just say this will be 3 to the power of 3 over 2. And then here minus log base b of 4. Now log base b of 4 is just n. So I could just put n there. And now for this one, I could pull, by the power law for logs, I can pull the 3 over 2 in front. So it's 3 over 2 log base b of 3 minus log base b of 4. And then that's just m. So this is 3 over 2m minus n, which is exactly what they wanted you to show. So it's just using the log laws. You should be really comfortable with the log laws, of course, at this point. And then you just have to remember that 27 is 3 cubed and 16 is 4 squared. It's definitely good to be familiar with the basic squares like that. Like if you see 81, it might be really useful to write it as 9 squared, you know? So it's good to know those things. Okay. Now part 2 is our log equation. It is actually one of the more difficult log equations, so I definitely suggest try it a bit before, and if you're stuck, it's very understandable. So it asks us to solve log base 2m plus log base m16 equals 4. Now, the first thing you should realize when you're solving this log equation, you see that the bases are different. When the bases are different, it's basically impossible for us to solve it just like as it is. So the first thing I always recommend is to make sure that the bases are the same when you're solving a log equation. How do we do that? Well, there's a real important formula that you need to know called the change of basis formula, or change of base formula. So I'll just write it out real quick. So it's saying that log base a of b is equal, if I want to change the base to anything, it's equal to log base c of b over log base c of a. So basically the previous base comes to the denominator, and then whatever you're taking the log of becomes the numerator. So because it's like a lot more comfortable, of course, working with 2 as the base than m, what I'm going to do is I'm going to change log base m16 to log base m2. So to do that, I'm just going to put log base 2. What was the thing inside the log before comes on the numerator, so log base 216 over, and then the previous base goes on the denominator, so over log base 2m. Now log base 216, you can just put it in a calculator. You'll see that that's 4 over log base 2m. So now I'm going to start solving the equation, and I'm going to replace the log base m16 by this expression, because now everything will be the same base. So I'm just going to write over the equation, log base 2m plus log base m16 equals 4. Now I substitute this into my equation, so log base 2m plus 4 over log base 2m equals 4. Now you should realize this guy is quadratic. What I'm going to do is I'm going to let x equal log base 2m. So then it becomes x plus 4 over x equals 4. So I just multiply by x. X squared plus 4 equals 4x, or x squared minus 4x plus 4 equals 0. This is a quadratic, you could solve it, and you'll see that the solution is just x equals 2. But remember, of course, we're asked to solve for m, so what I can say is log base 2m equals 2, and then just undoing the logs, m is equal to 2 to the 2, which is equal to 4. That's how you solve this equation. I definitely think this is one of the more difficult log equations I've seen because it requires you to use change of base. But you need to know change of base too, and once you know change of base, it's not that difficult. You definitely should be able to solve this question. Okay, part B now asks us to use mathematical induction to prove that 7 to the n minus 1 is divisible by 6 for all natural numbers n. So what I'm going to start is, the first thing you need to do in mathematical induction is to define your proposition. So we start by saying let P of n be the proposition that 6 divides 7 to the n minus 1. So the first thing in an inductive proof is the base case. So that'll be P of 1. Well, 7 to the 1 minus 1 is equal to 6. This is divisible by 6, obviously, right? Because 6 over 6 is just 1. So then we could say P of 1 is true. Now I have what's called the inductive hypothesis. I'm going to assume that P of k is true. That is that 6 divides 7 to the k minus 1. Now I have to do the inductive step. The inductive step is I'm looking at 7 to the k plus 1 minus 1. So the first thing is from the inductive hypothesis, we can write 7 to the k minus 1 is equal to 6 times m, right? So that means that 7 to the k is equal to 6 times m plus 1. Now, that means that 7 to the k plus 1 minus 1, well, by the laws of indices, it's just 7 times 7 to the k minus 1. And I'm going to use the inductive hypothesis. It's 7 times 6m plus 1 minus 1, which is then 42m plus 7 minus 1, which is just 42m plus 6. But I could factor 6 out of this. That's like the whole point. 6 times 7m plus 1. So 6 also divides 7 to the k plus 1 minus 1. Thus, P of k plus 1 is true. So once you've done this, you've actually proven the claim. It's just now to summarize everything, so you can write it in a sentence like this. We've shown that P of 1 is true, and that if P of k is true, then P of k plus 1 is true by the principle of mathematical induction. Then P of n is true for all n, which is exactly what we wanted to show. All natural numbers n. You can put a little box here to signify that you're done with your proof. Okay, induction tends to be one of the more difficult topics, but I would say this is a very standard induction question. So it's very good to be familiar and be able to do a question like this without too much trouble. Okay, now let's move on to the last part, which is on binary operations. Binary operations is one of the things that it might be kind of easy to forget, but it does show up from time to time. It showed up here, so it's good not to forget and make sure you cover it. A binary operation star is defined by x star y is equal to x to the 1/3 plus y to the 1/3 cubed. And then we're asked to find 8 star 27. So wherever I see x, I just put 8. Wherever I see y, I just put 27. So 8 star 27 is equal to 8 to the 1/3, and then plus 27 to the 1/3 cubed. You can literally just put it in your calculator at this point. 8 to the 1/3 is 2, and then 27 to the 1/3 is 3 cubed, and then that's 5 cubed, which is 125. That's all you have to do. And then we'll have to show that star is commutative. And the kind of difficult thing is you might forget what commutative means, but just to remind you, commutative means that x star y is equal to y star x. This is what it means to be commutative. So what we have to do to show something is commutative is, let's first write what x star y is. That's x to the 1/3 plus y to the 1/3 cubed. And now let's write what y star x is. That's, well, now it's going to be y to the 1/3 plus x to the 1/3 cubed. But you know, addition doesn't matter the order, so I could definitely switch those around. X to the 1/3 plus y to the 1/3 cubed. And now these two are the same. So it's equal to x star y. And then you'll just say something like, since x star y equals y star x, star is commutative. So once you know what commutative is and what it means, and you have like a little practice, it wouldn't be too difficult to do a question like this. However, the difficulty might be you forget what commutative means. So it's important just to be, like, just make sure you don't forget those things. Commutative, associative, distributive, what all of those things mean.